Okay, we've been talking about electric circuits, and we have these two different models for current. One based on the electric field and one based on this Ohm's law. And then we have the two circuit rules. So we have this. We have Ohm's law, which says that the change in potential across some element is equal to I times the resistance of that element. And then we have the loop rule, and I'm going to use this resistance model. We have the loop rule, which is based on the work energy principle. This says that delta V around a loop is equal to 0. And then we have the junction rule. And this is for a node. This says if you look at the current coming into the node, is equal to the current coming out of the node. So I in equals I out. And you can do a lot with this. So what happens if you have multiple resistors in series? So let me first define series. What does series mean? Series means that two items, they don't have to be resistors, they could be two items. They share one contact point. So there's a node between them with no other wires, just like this. So since we have the junction rule, another way to think of resistors in series is if there's a node in between them with no other wires, then the current coming in resistor 1 through resistor 1 has to be equal to the current through resistor 2. So this is one way to say it, is they have the same current. Okay, now suppose that I want to take this circuit with two resistors, R1 and R2, and build an equivalent circuit, which is one resistor, R equivalent. So what would the value of this one resistor be? So let's go over here and do the loop rule for this circuit. So the loop rule says if I start at this point and I go around the loop, I have to add up to 0 voltage. So I'll start right here and go across the battery, and I get EMF. And then I go across R1, I get minus I R1, because I is in the direction of the electric field, and so the change in potential is negative E dl. That's why there's a negative sign there. And then I do R2, I get minus I R2 equals 0. So now since these have the same current, I can factor that out, and I get EMF minus I times R1 plus R2 equals 0. So if I want the same exact current, if I say R equivalent is equal to R1 plus R2, then I would get the following equation: EMF minus I R equivalent equals 0. These two are identical because I have R1 plus R2 right there. So if I have two resistors in series, then their equivalent resistance, I just add them together. What if I have three resistors in series? R1, R2, R3. Then in that case, R equivalent is going to be equal to R1 plus R2 plus R3. And you could see this because if I have the same current going through them and I do the loop rule, I can factor out the I and I'll get that term. So anytime you have any number of resistors in series, you can replace that with one resistor in that is the sum of those resistors. Now let me show you one more thing for resistors in series. I'll do it in the next video. In the next video, I'll show you how to use resistors in series as a voltage divider.